Applications of quadratic equations. Our learning goal today is to use appropriate techniques to solve problems involving models based on quadratic equations. Please ensure you have the lesson printout so you can follow along with this video. Today's lesson is all about solving problems based on quadratic equations. We're going to use the full tool set that we've learned throughout the different lessons of this unit and past units to solve these problems. So let's jump in. Number 1, a football player kicks a field goal. When the ball passes through the goalposts, it's at a height of 3.15 meters. The height of the football can be represented by the equation h is equal to negative 0.6 t minus 2.5 squared plus 3.75, where h is the height of the ball in meters and t represents the time in seconds. Before we begin, let's just examine what this equation is telling us. We have h standing in for y, so that's our vertical axis here, and we have t standing in for x, and that's our horizontal axis here. So we have time and height. And we can see that it's in vertex form, and so we'll know where the vertex is from our h and k. And we know that a is negative, so the parabola opens downward. So we can imagine the football flying through the air like this. And we know, again, our vertex is going to occur right here, and that's going to be at 2.5, 3.75. So at 2.5 seconds, it's going to reach a maximum height of 3.75 meters. So let's try example A here. Determine the height of the football after 1 second. So t is equal to 1. So what we need to find out is what height is when t is equal to 1. So all we have to do is plug in 1 into this equation. So let's go ahead and do that and solve for what h is when t is equal to 1. We have h is equal to negative 0.6 bracket t minus 2.5 squared plus 3.75. And to that, we're just going to plug in t is equal to 1. So h is equal to negative 0.6, 1 minus 2.5 squared plus 3.75. Okay, and if we calculate this, 1 minus 2.5, that's going to be negative 1.5 inside the bracket here. And then we'll just write this here again, negative 0.6 and plus 3.75. Then we just got to square negative 1.5 inside there, and we're going to get positive 2.25. And again, we have the 3.75 and the negative 0.6 out here. So I'm just going step by step here so you can see what we're doing. And then we're going to multiply this 0.6 into this 2.25, and I'm just going to bring that up here to do it. So h, so we're going to rainbow that into there. So we're going to get negative 1.35, and we still have that plus 3.75 at the end there. And so we're just going to add these two together to get our h. h is equal to 2.4. And so we can conclude this. We can say, therefore, the height is 2.4 meters after 1 second. Let's try part B. How long does it take the football to reach the height of the goalpost? So we want to figure out how long it will take. So what is t when the ball reaches the height of the goalpost? And the h here is 3.15. So what is t when h is equal to 3.15? Okay, so we know what h is, so we can plug that into our equation. And then all we're doing here is solving for t. So let's go ahead and try that. We're going to set h to 3.15, and so let's write that in. Let me zoom in a little bit. So we have 3.15 is equal to negative 0.6 t minus 2.5 squared plus 3.75. Okay, so the first thing we're going to do is we're going to get rid of this 3.75 on this side, and we're going to bring it to the other side over here. So we're going to get 3.15 minus 3.75 is equal to negative 0.6 t bracket 2.5 squared. And so when we do that, we're going to get 3.15 minus 3.75, and we're going to get negative 0.6 is equal to negative 0.6 bracket t minus 2.5. And then the next thing we want to do is get rid of this negative 0.6 over here. And so to do that, since we're multiplying it on this side, we can divide it out on both sides. And this is going to cancel this. So negative 0.6 divided by negative 0.6 is just 1, so we don't have to show it. And on this side, the same thing's going to happen. So we're going to have 1 is equal to t minus 2.5 squared. Okay, and now we need to solve for t, and to do that, we need to get rid of the square. So we have to take the square root of both sides. And as you remember from our last lesson, this is going to give us plus or minus 1 on this side. The square root of 1 is a 1. So we're going to get plus or minus 1 here, and we're going to get rid of the square here. So we have t minus 2.5. And this is going to split up into two different values. As you can imagine, there are probably two different points on our graph. Let's look at the graph again, where our height is going to be equal to 3.15. Okay. So let's see what times those occur at. So let's split this up. So let me rewrite this so the t's on the other side. I like it like this. 2.5 is equal to plus or minus 1. So I just rewrote this with plus or minus 1 on the other side instead. And let's split that up into the two cases here. So we have t is equal to plus 1 plus 2.5, or t is equal to minus 1 plus 2.5 when we move it over. So we're just moving this over here. So when we move it over here, we're going to get plus 2.5 or negative 1 plus 2.5. Okay, and we're going to get a t value of 3.5 over here and a t value of 1.5 over here. So those are the 2 points, the 2 times. If we look up here, we're going to get a height if we measured it here and here. If this was, what was it, 1.5, and this was 3.5, we know what the height is here is going to be 3.15. So that's all we solved for. And so we can conclude here, therefore, it reaches a height of 3.15 meters at 1.5 seconds and 3.5 seconds. Part C. How long does it take the football to reach the ground? So if you can imagine here, where would it hit the ground? What would our height be when it hits the ground? It would be a height of 0. So we know when it hits the ground, h is equal to 0. So we want to solve what the time is when h is equal to 0. Okay, so how long does it take the football to reach the ground? How many seconds pass till h is equal to 0? So let's go ahead and do this. So we want to set h to 0, and we'll rewrite our equation. H is equal to negative 0.6 t minus 2.5 squared plus 3.75, and we know h is equal to 0. So we're going to set h to 0, and we're just going to go through the steps of solving this. Okay, and so the first thing we're going to do is we're going to move this over to the other side. So we're going to get negative 3.75 is equal to negative 0.6 bracket t minus 2.5 squared. And just like before, we want to get rid of this a term here. So we're going to divide both sides out by negative 0.6. So let's do that. So 3.5 divided by negative 0.6 is 6.25. So I'll just bring that up here. So 6.25 is going to be equal to, this is going to cancel, t minus 2.5, and that's all squared. And again, we want to get rid of the square root, so we're going to go ahead and do that. And there we go. And so we're going to get plus or minus the square root of 6.25, and the square root of 6.25 is 2.5. So we're going to get plus or minus 2.5 is equal to t minus 2.5, because we got rid of the square now. So all that's left is to solve for what our t value is. And I'm just going to rewrite this again. I like to have it on the right side, like this. So we're going to have plus or minus 2.5. And we're going to move this over here. And so we're going to get our two cases. So t minus 2.5 is equal to positive 2.5. Or t minus 2.5 is equal to negative 2.5. And so if we go and solve that, we move this over here. We're going to get t is equal to 2.5 plus 2.5, which gives us a t of 5. Or we're going to get, if we move this over here, t is equal to negative 2.5 plus 2.5, and this gets us a t of 0. So this tells us that at time 0, the height of the ball will be 0, so it's on the ground. And at the time of 5 seconds, it's also on the ground. And we're only interested in how long it takes for it to hit the ground once it's kicked. So the time that we're really looking for is after 5 seconds. So we can conclude the ball reaches the ground after 5 seconds. So let's try our next example. A ball is thrown upward at an initial velocity of 8.5 meters per second from a height of 1.5 meters above the ground. The height of the ball h in meters above the ground after t seconds is modeled by the equation h is equal to negative 4.9 t squared plus 8.4 t plus 1.5. Before we begin, let's just look at this equation. What do we know from this? Here it's in standard form, so there's not a lot of information given. We don't know the vertex or anything like that. But again, like our previous question, the y value is going to be represented by h. So that's our vertical axis, and t, again, is our horizontal axis. And we know the ball is thrown from an initial height of 1.5 meters. So when t is equal to 0, we know the height of the ball is 1.5 meters, and the a value is negative, so we know it's opening downwards as well. So it's going to be very similar. We just don't know the same information as before. So the question here says, determine the height of the ball after 0.5 seconds. And again, we just want to figure out what h is when t is equal to 1.5. So this one's a simple question again. So we just have to plug in a t value of 1.5 seconds, and that'll tell us the height of the ball at that point. So if this is 1.5, it'll give us what our height value is if we plug that in. So let's go ahead and do that. So h is equal to negative 4.9 t squared plus 8.4 t plus 1.5. And h is equal to negative 4.9 bracket 0.5 squared plus 8.4 times 0.5 plus 1.5. And following our BEDMES rules, we must square this first before multiplying that negative 4.9. So let's do that. 0.5 squared, that is 0.25. So we'll have h is equal to negative 4.9, and again, 0.5 squared is 0.25. And then I'm going to multiply this one here. 8.4 times 0.5 is 4.2, and we still have our 1.5 at the end here. And so we just have to multiply these two together here. So we have 0.25 times negative 4.9, and that's going to be equal to negative 1.225. So h is equal to negative 1.225 plus the 4.2 plus the 1.5. And we can add all those together, and we're going to get an h value of 4.475. And just be careful with your negative values here and there. If you just plug that into a calculator, you get 4.475. And so we can summarize then at 0.5 seconds, the ball will be at 4.475 meters. So the height of the ball is 4.475 meters at 0.5 seconds. So let's try example B here. After how many seconds does the ball land on the ground, round to the nearest tenth? So if we think about our graph from earlier, we have our height here, we have our time here, and we're looking for the time when the ball hits the ground. And when the ball hits the ground, we know h is equal to 0, just like in our last question. So let's go and set h to 0. So 0 is equal to negative 4.9 t squared plus 8.4 t plus 1.5. And so if we think about where the arc of the ball is going, when it hits the ground, when it touches the t-axis or x-axis, it's intercepting that axis. So it's like the x-intercept. So really we're just looking for the x-intercept here. And in place of x, we're using t. And to do that, we use well, there's a couple ways to do it. We can factor it out and solve for what our zeros are. Those would be our t's. Or we could use the quadratic equation. So let's go ahead and use the quadratic equation. So we're going to be solving for our t-intercepts or x-intercepts. So t is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so let's just start plugging in our values. Before we do that, let's just list what our a, b, and c are. A is negative 4.9, b is 8.4, and c is 1.5. So let's plug in. We're going to have t is equal to b, negative b, which is negative 8.4. We'll put it in brackets, plus or minus the square root of b squared, which is 8.4 squared, minus 4 times a times c. A is negative 4.9. C is 1.5. All divided by 2a, which is 2 times negative 4.9. Okay, so let's go ahead and start simplifying this. T is equal to negative 8.4 plus or minus the square root of 8.4 squared is 70.56. And then we're going to add these next three things together. So we have negative 4 times negative 4.9. So it's going to be positive 19.6 times 1.5. So it's going to be positive 29.4 all over 2a. So 2 times negative 4.9. which is negative 9.8. So let's simplify what's in the bracket here. 70.56 . plus 29.4 is equal to 99.96. So we're going to have t is equal to 8.4, negative 8.4, plus or minus the square root of 99.96, and all divided by negative 9.8. And here we can take the square root of 99.96. It's almost 100, so we can expect the square roots to be close to 10. So t is going to be negative 8.4 plus the square root of 99.96. Let's see what that is. 99.96, the square root of that, 99.96 is equal to 9.99, so it's equal to 10. So it's plus 10 divided by negative 9.8, or, this is where it splits up again, negative 8.4 minus 10 over negative 9.8. So let's solve for what our t values are for each one of these. So we have negative 8.4 plus 10, which is 1.6, divided by negative 9.8, which is equal to negative 1.63. So it's a time of negative 1.63, or negative 8.4 minus 10, which is negative 18.4 divided by 9.8. And we're going to get a t of 1.877 seconds. So we can see here we have a positive time and a negative time. And the only one that makes sense is the positive time, because we can't go back in time. So this is going to be our answer. We know the ball will hit the ground after 1.877 seconds. Okay, and it says here round to the nearest tenth, so 1.9 seconds. And if we think about this negative time, that's where it would have been on this side if we completed the parabola. So we'd have to go backwards in time. Okay, so we're only concerned with this positive time because it's the only one that makes sense. So let's conclude over here. Therefore, the ball will hit the ground after 1.9 seconds. So let's move on to the next part of this question. What is the maximum height that the ball reaches round to the nearest meter? So we can see here the key word is maximum, and we know a maximum or minimum is talking about the vertex. So what the question is really asking is, what is the vertex of this equation? So let's write our equation down here. We have h is equal to negative 4.9 t squared plus 8.4 t plus 1.5. And we can see it's in standard form. And we know a technique to get it into vertex form. And that technique is called completing the square. So what we have to do to complete the square, we need to get the t squared value by itself. So from these first two terms, we're going to factor out negative 4.9. And we're going to be left with t squared minus 1.714 t. And we have that 1.5 on the outside. The next thing we need to do is add half b squared and subtract half b squared. And these numbers are going to get pretty ugly. They're not nice numbers to work with, but we just have to go through all the steps. So 1.714, we have to divide it by 2 and then square it. So let's just figure out what that is. So if you have your calculator handy, 1.714 divided by 2 is equal to 0.857, and then we have to square that. So just plug that into your calculator, times 0.857, and we're going to get this really small number, 0.73449. Okay, so we'll just round that actually to 0.73. So we'll leave it like that. And then we're going to plug this value in. We have to add this and subtract it right after our b value here. So we get h is equal to negative 4.9 bracket t squared minus 1.714 t plus 0.73 minus 0.73 close bracket plus 1.5. And now what we need to do is just factor these first three terms. And as we know, it's going to factor into a simple trinomial, perfect square trinomial, I should say. And the x value is going to be equal to, actually, half of the b. So it's going to be equal to this number here. So when we do this, you're going to get t minus 0.857 squared, and then we still have this negative 0.73 out here and plus 1.5. And before we can finish up here, we have to just multiply this into here so we can get what our k value is at the end. So h is equal to negative 4.9 t minus 0.857, and then we do 4.9, negative 4.9 times that 0.73, and we're going to get 3.57 plus 1.5. So we're to the 1.5, we're going to add the 3.57. We're just adding these two terms at the end, and we're going to get an h of 5.07. Okay, and so now we have our vertex, which is right over here. And so if we rounded that to the nearest meter, it's going to be 5.1 meter. Actually, the nearest meter would be 5 meters. So we can conclude, this is the max height over here. The max height is 5 meters, and it occurs at 0.857 seconds. Okay, it's a pretty complicated question, and I think in the homework it's not as bad as this one, but try it out. Some key things is when we're factoring to our perfect square trinomial, it's this value here is always half of b. So it's what's in this bracket over here. And so the rest of the homework is going to be variations on these types of questions. So break it down and try to reason out what you need to do and what you're solving for. And then just use the techniques that we learned and apply it. And I don't think they're as complex as this one. So try it out.